A very good morning, children. So today we are going to continue the fourth unit, which is plasma membrane. So in the last unit we have learnt about the actions of plasma membrane and also transport of different substances through the membrane, right? So and now we are going to continue the transport across the membrane with an example, right? So for that example, to understand it better, how the transport of materials takes place through a membrane. So to understand that a bit clearly, so what we are going to do here, we are going to make a experiment here. So here in this experiment, what are the materials required here? Raw eggs, HCl, or the toilet acid which you use in your toilets, and then a petri dish, a strip of paper so that you can measure, right? And then tablespoon and also a cloth to wipe. So these are all the materials required, and if these materials are with us, we can go ahead with this experiment. Okay, first of all, what we have done here is we have taken a beaker here. And in this beaker we have filled this beaker with the dilute HCl. We have to make sure that it is not concentrated HCl. That is really very harmful to us, so we should not use the concentrated HCl. So instead of that, we should go ahead with the dilute HCl. So here what we are doing here is we are taking the dilute HCl here, and in this dilute HCl, already we said that we are taking the raw eggs, no, right? We are taking them in 2 in number. So I'm putting those 2 eggs here in the dilute HCl. So you'll keep this apparatus as it is for around 4 to 5 minutes. So what will happen after 4 to 5 minutes? So what we have done here is we have kept the 2 eggs in the HCl, that is dilute HCl. And if you observe after 4 to 5 hours, you see that the shell, which is on the upper layer of the egg, is completely dissolved in the HCl. So you cannot see the outer shell of the egg. So in the shell, okay, now for example, if you take the egg, there are 2 layers. You see, even when you try to break the egg also, you can see a thin membrane after the shell, isn't it? So but even though the shell is completely dissolved, the layer which is inside, the transparent layer which is inside, that is still present, and that will protect the internal parts to come out. So this egg will stay intact and it will have the internal membrane. And now what you have to do is you have to use the spoon and you have to remove the 2 eggs from the dilute HCl. So directly don't put your hand and remove them. Okay, there are chances that your hands will get burnt. So that's why what you have to do is you have to remove them using a spoon. That's why in the equipment we have taken a tablespoon. So use a tablespoon and remove that eggs. So now after removing eggs, what we will do? So after removing the eggs out, we have to take a strip of paper for measurement. That is what we have taken. So you have to take the paper which is thinly cut, which has some measurements on that, and then you have to take the length and also the circumference of the egg. You have to measure exact measurements of the egg, I mean the length and also the circumference of the egg. So after doing this particular measurement and all, write them on a paper. So after taking the measurements in the paper, then we have 2 eggs which we have the right measurements, and we have taken the measurements on the paper. Now after taking that, again we have to take 2 beakers, okay, and in one beaker we are filling it with the concentrated salt solution. You know already what is saturated salt solution, right? So already we have prepared the concentrated sugar solution and the salt solutions. So here in one beaker, what we are taking here is we are taking the salt solution, and in the other beaker we are taking the tap water. So here salt solution So we have taken the salt solution here, and here we are taking the tap water. So now what we have to do is, we have to put the 2 eggs, right? 1 egg here and 1 egg in the tap water. So after putting those 2 eggs in the, one in the salt water and other one in the tap water, what we will observe? So leave it for 2 to 4 hours. Leave this apparatus exactly as it is for 2 to 4 hours and don't remove them before that. So now 1 egg we have put in the concentrated salt solution, and the other one we have kept in the normal tap water. So after 2 to 4 hours, when you observe the 2 eggs, what are the differences you can find? So already we have taken the measurements. So is there going to be any change in the measurement? Okay, that is what we are going to see. Is there any swelling in the egg, or if the egg is becoming thinner? So that is what we are going to check now in these 2 experiments. So first of all, we'll talk about the salt solution, right? So the egg which we have taken in the salt solution. So here what happened is, now already this is a concentrated salt solution. So the egg which we have kept in the salt solution, basically this solution will shrink. This egg completely will shrink. So here, now in this situation, what happened is, the water which is in the egg, that has entered into the salt solution. So that is the reason why what happened here, the egg has completely shrunk into size. So here the egg has shrunk. Okay. The egg shrinks here. Okay, the egg which you have kept in the salt solution, that has shrunk. Okay, and after that, now what is the reason behind this? Because the water molecules which were in the egg entered into the salt solution. And this one we call it as osmosis. This process we call it as osmosis. What we call it as osmosis. So what is happening in the osmosis? The water molecules leave the cell. The water molecules are leaving the cell here, and they are entering into the salt solution which is in the beaker. That is what happened here in the egg which we have kept in the salt solution. Okay, now we'll go to the other one which we have kept in the tap water. So here what happened is, here the water molecules from the water molecules which are in the beaker entered into the egg. So now here you can see that the egg swells here. If you see the egg, it is swollen. The reason is that the water from the beaker has entered into the egg, and this process is called as the endosmosis. It is called as the endosmosis. So here we can see 2 things here, right? One we have taken in the salt solution, 1 egg we have taken in the tap water. So the one which we kept in the salt solution has shrunk a little bit. And how can you say that it shrunk? Again, you can take the measurement of the egg and then compare with the previous measurements. And also here, how can you say that it is swollen? Because already we have taken this measurement, and now what we can do is we can also check the measurement of this particular egg and also compare with the previous one. So when you do that, you can definitely find this is a bit swollen and it is shrunk in size. So what is the difference here? Here the water came out of the membrane. Here the water entered into the membrane. So when the water molecules leave the cell, we call it as exosmosis, and then if the water molecules enter into the egg, we call it as end osmosis. Okay, so now this is the one of the very important activity. Okay, and also now what we are going to see is how we can make prepare a semi-permeable membrane. Now we can see here this particular membrane is acting as a semi-permeable membrane. You can see here in these two beakers, we have seen that this is preventing something to come inside and also letting out something to go outside. Here it is preventing something to come in, it is also allowing something to go outside, and in both cases the things are completely different. The water is coming here and the water is being exit here. So now that's the reason why we can call it as a semi-permeable membrane. So what we are going to do now is we are going to make a semi-permeable membrane. So how to make a semi-permeable membrane, we will see it now. Okay, so already we have discussed that when you break a egg, okay, you can see a very thin membrane in the egg after the eggshell. So after the eggshell, you can observe a very thin membrane, and this membrane is actually acting as a semi-permeable membrane. This membrane is acting as a semi-permeable membrane. So it is allowing certain things to go inside, it is allowing certain things to come outside. So now we can call it as a semi-permeable membrane or a selectively permeable membrane. So how to make this semi-permeable membrane, so that we can do one or two activities. So here what we can do here is, again we will do the same experiment. So what we have done is, we have taken a beaker, we have taken the dilute HCl here or toilet acid, and then we have kept an egg here. So what happens when you keep an egg? The shell, which is made up of the calcium carbonate, will get dissolved in the acid, in the dilute HCl, and what will be left? The membrane and also the internal parts of the yolk and the albumin. So what you can do is, you can just take a small pin and puncture it and remove, and don't make a very big hole and all, so that you just make a very small hole and make sure that all the things which are inside will get out. Okay, you push them outside. So you just try to make sure that the complete membrane is completely empty. So you empty all the contents of the egg. Okay, so what you have in your hand is only a membrane. That is what you have in your hand. Now this one is nothing but the semi-permeable membrane or a selectively permeable membrane. Now what we have to do is, we have to wash this with the fresh water, and now that particular semi-permeable membrane is absolutely ready for any kind of experiment. So we have a very small activity with this semi-permeable membrane. So children, till now we have seen how to make a semi-permeable membrane. So if you fail to make a semi-permeable membrane, you cannot work out on this experiment. So this experiment will not come the best. So what we are doing here is, whatever the egg you are putting in the HCl and all, and when the calcium carbonate completely dissolves in that, and the membrane, the thin membrane which you get that. So what you have to do is, you have to take a pencil, and with the pencil you just make a pencil. Okay, using the pencil you just make a small hole here. So what happens here is, now there will be a hole which is formed here, and now you try to drain out all the things which are in the egg, so that you can get a complete egg like this. So that means, so you should get an egg like this with a small hole, so that you can put some ingredients into that, you can put some contents into that. So now here what we require for this experiment is, we require two such membranes which have a very small hole like this. Okay, so after doing this, okay, after getting this, what we have to do here is, you have to observe here children very carefully what I am doing here. What I am doing here is, I am filling this one of the egg membrane using a syringe. What I am doing is, I am filling some using a syringe. I am filling some, 10 ml of saturated sugar solution. saturated sugar solution. So in the first egg membrane, what I filled here? I filled saturated sugar solution. Okay, so let me write like this. So here, the first one I have taken 10 ml of saturated sugar solution, which is absolutely concentrated in nature. And the second one, what I am doing here is I am taking the tap water. The same 10 ml of tap water. I use the same, the syringe to insert the water in it. So now this one is with tap water and this one is with the concentrated sugar solution. So what I will do is I will try to tie this with a thread so that the contents will not go out. Okay, so I tied with the thread here. So I tied it as a like you make a balloon, no? So but you have to do this very carefully. If some cut happens to this, if this membrane is cut, then this will not be useful for the experiment. So now after doing this, what I am doing here is I am taking 2 beakers here. In one beaker I am filling it with the complete 100 ml of water. I am filling it with the 100 ml of water. Let me write here 100 ml of water. And in the other one, in the second beaker, what I am taking is I am taking the same 100 ml of sugar solution, saturated sugar solution. So in the first beaker, what I have taken here, I have taken just 100 ml of water, and in the second beaker I have taken 100 ml of saturated sugar solution, that is concentrated sugar solution. Now what I'm going to do here is I'm going to take this one. Okay, I'm going to take this one which is filled with the 10 ml of saturated sugar solution and keep in this 100 ml of water. In the same way, I'm going to take this membrane, that is which is having the 10 ml of tap water. I'm going to leave it in the 100 ml of saturated sugar solution. I'm going to leave this apparatus overnight. So I'm going to leave this apparatus completely overnight. So if I leave this overnight, when I see the next day, what happens? We'll observe what happens in the first one. So what I've taken here, I've taken 100 ml of water in the beaker, and what I've taken here, I've taken 10 ml of saturated sugar solution. So when you take the 10 ml of saturated sugar solution here, and when you take the water here, so where is the more concentration? So what happens is, here the water which is in the, so here in the first beaker where we have taken the 100 ml of H2O and 10 ml of saturated solution, you can see that this particular membrane will get swollen, it will swell because there is entry of water from the beaker into the membrane. So definitely it will swell. And when you come to the second one, here you can see that here there is water in it and here there is saturated sugar solution. So what happens is the water which is in the egg will move from this into the beaker. So here also what you can see is this particular egg will shrink in its size. So before that you can take the measurements again with the paper. Using the strip of paper you can take the measurement, and after that, after the next day, so you can take the measurements of the eggs. So definitely you can see kind of swelling here because the water from here has entered into the egg, and here the water from the egg entered into the beaker. So this is the process which we call it as the osmosis. Osmosis is nothing but molecules moving from the lower concentration to the higher concentration. So this is what we learn in these two experiments.